Hello everyone from the Novedge team. Welcome to today's webinar. Get started with Thea for Rhino. Thea Render is a biased, unbiased, and GPU accelerated renderer with lots of innovative features and a powerful material system. Today's presentation will be focusing mostly on the GPU renderer called Presto. You will be guided through the material creation process, look development, and staging of a scene. Our webinar presenter, George Gliatis, is a 3D artist that joined the Thea Render team in 2015. He's now working as an application specialist for the Thea Render products, providing tutorials and support for end users. But before we get going, here's an overview of what we do in Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Twitter, and Google+. Coming up next week, there won't be a Novedge webinar. The Novedge webinar series will be off for a couple of weeks, but Novedge will be open for business. Now more than ever, if you want to put all your budgets to go use, reward yourself, grow your design, and save. We're here and we'll be waiting for you to check us out. Last but not least, today's webinar is free and is being recorded live. So if you want to rewatch this or any webinar episode in our collection, just head on over to the Novedge's YouTube and Vimeo channels. And now without further ado, I'm going to share George's screen and make him the sole presenter. And I also want to remind everybody that Patrick Nieborg is on the online with us today, and he'll be helping with answering the questions at the end. Take it away, George.
Thank you, Barbara. Thank you for the introduction. Welcome everybody to this webinar. My name is George Gliatis. I am a 3D artist, part of the Thea Render team. With us we have Patrick Nieborg. He's also a 3D artist and a graphic designer. He's also part of the Thea Render team. And together we will be answering any questions at the end, so feel free to write down any question that may come up, and we will be happy answering them at the end. So in this webinar, I would like to guide you through the Thea for Rhino workflow, and I will be doing this with a practical example. I have created a scene just for that. But before jumping into Rhino, I would like to make a brief introduction to Thea Render, just in case anyone is not completely familiar with the Thea Render-Engine. So let's go. Thea Render is an unbiased, biased, and GPU renderer. The unbiased engine is the state-of-the-art and highly optimized render engine. The biased solution is based on field mapping and final gathering techniques, giving user control of all the features at the expense of setup time. Now the GPU engine is called Thea Presto, and we will be mainly focusing on that. So let's see some more information about Thea Presto. The Thea Presto engine will use all the computing power of your system, and that means that you will use any NVIDIA GPU found on your system along with a CPU. It has been designed for a very fast interactive rendering, and of course it's physically based, and by that I mean it's physically accurate with materials that obey the laws of physics. Now Thea Presto can operate in two modes. The first one is the interactive mode, where you get instant feedback inside the viewport, while the production mode can be used to create your final renderings in the highest quality. The Thea Presto engine comes in two variants. There is the Presto AO engine. It has been designed for interactivity, while the Presto MC engine can be used to create truly photorealistic images. Now, what these engines both have in common is that they have a minimum set of parameters, and that means that they have less settings to mess with and a very quick setup. Now, in more detail, the Presto AO engine uses ambient occlusion to mimic a part of the global illumination in the scene, and it has been tuned to be very fast, and you can even create convincing final renderings. Presto MC, on the other hand, can be considered as an unbiased-like engine, and by that I mean that it uses the logic of an unbiased engine, but with extra tuning that reduces render time but also adds bias in the final result. To reduce bias, we can do this by increasing the tracing depth of the engine. You can also create truly photorealistic images, and this is due to the fact that it has an unbiased-like nature. Now, one of the most important things of the Thea Render-Engine is the Material Lab. The Material Lab is physically based. That means that materials do not violate any laws of physics, and they have been developed on an analytical physical framework. The way you work with materials, it's layer-based, and that means that you can create different layers and you can stack them one on top of the other or mix them together to create complex materials. One of the most important features of the Material Lab is its unique material scheme. It's the one that you see at the middle of the screen. You can think of it as the anatomy of material, and if you take, for example, this car paint material, it has three layers. The first one that you see at the bottom, this is the base metal shader. The one on top, in the middle, is the flakes for the car paint, and on top of all this we have the coating. So the material scheme provides a very easy and logical way to create materials. Now, advanced materials can be created by using layers, and they are basic glossy SSS thin film coating, and you can mix them all together, and each layer has its own layer weight, so you can create very complex materials. Finally, along with the Material Lab, we have the Texture Lab, and you can tone map your textures. You can change the mapping coordinates of every texture, and it's very helpful when you want to use the same texture in different channels but with different settings. So if you want to use a colored map in the BAM channel and you want to remove the color to desaturate it, you can do this with the Texture Lab. So let's move on to our standalone application, the Thea Studio. It has a common interface for Windows, Mac and Linux, and it has been designed to be a full stager, and this means that you can import your model and stage your scene by adding lights, materials, and you can produce final renderings. It also has an OpenGL viewport that you can navigate your scene that can be turned into interactive rendering. It also has the darkroom where you can produce your final renderings, and of course it has the advanced material editor and the Texture Lab. Animation is also possible inside Thea Studio with support for object, lights and cameras. There are also ways to create walkthroughs and turntable animations. Now the next slides have to do with some advanced features of the Thea Studio and the Thea Render-Engine. The first one is called Relight. It's an interactive way of manipulating lights in a render, and you can create different images or even videos from a single frame, and that means that you can create one rendering and start playing with the lights intensities and their color, and you can animate them through a timeline and create a video. The next feature is instancing. It's a tool for scattering proxies on surfaces with advanced settings for randomizations like density, proxies scaling, and map-based scattering. Finally, Thea Studio provides Colimo support. Colimo is a software that's been used to modify materials and lights on pre-rendered images. You can create unlimited combinations and images just from one rendering. And what Studio does is to provide a direct export to the Colimo format. Now, with that said, we can go with our presentation of the Thea for Rhino plugin. And I would like to start my presentation with an introduction to the interface. So the first time that you open Rhino after having installed Thea for Rhino, there is a new menu entry at the top called Thea Render. In here we can have access to the preferences, update, and we can license the plugin. Now with the update, we do not only update the plugin, but we can also download material collections, models, skies, and other things. Now there's a new toolbar, the Thea toolbar that you see here. With the Thea toolbar, we can start, stop interactive rendering inside viewport with the first buttons, and we can save the image that is being displayed on the viewport at any time. We can open Thea Darkroom that we will see later on. We can open Thea Render Settings. We can create new materials, and we can open the Sun and Sky tab to enable physical sky. The rest of the buttons, import and export render settings, they import materials and models in the scene. It is essential to have two tabs open at any time. The first one is the Thea Render Settings. We can open it by clicking on the Thea Render button, Thea Render Settings button. In here we have three tabs. The first one has to do with the parameters of our render engine. We can switch between interactive and production mode. We can select our render engine. We also have the environment tab from where we can change the physical sky settings, and we can also enable image-based lighting. Finally, there's the camera tab. In here we can define the final resolution of our render. We can change the lens parameters, but we can also enable depth of field. The second tab is the materials tab. It's very important to have also this one because we will be creating all our materials in here. At last, one thing that I would like to point out here is that Thea Render needs to be the current renderer in order to make the workflow nicer. So we can do this by going to the render menu and select Thea for Rhino from here. So what this basically does is that we can have specific properties for objects. If we go to the Properties tab, there are buttons with specific properties for the Thea materials, and the same thing happens with lights and the way the dialogues correspond when creating new materials. We go straight to select the material type, and we have a new material type called Thea Material. So this was the basic things about the UI of Thea for Rhino. And let me open our scene. Okay, I would like to say some things about this scene. This is a guitar amplifier. It is pocket-sized. I have one of these at home. I have also created a 9-volt battery just to have a scale for the model. What I will be showing you with this scene we will examine, I will show you interactive rendering. We will be adding Rhino lights to create a studio setup. We will be creating and applying materials to this model. We will set up the environment using image-based lighting and physical sky. And finally, we will stage our scene. We will change camera parameters, and we will produce our final renderings in Thea Darkroom. So let's start using Thea for Rhino. To start viewport rendering, we can do this by pressing the first button. Interactive rendering starts right in the viewport. And if we go to the render settings and the rendering tab, you will see that we are in interactive mode and we have Presto AO selected. One thing you'll notice is that we may not have any lights in the scene, but we can see it being lit, and this is due to the fact that ambient occlusion is on. If we turn this off, we get a black image. So this is basically how Presto AO works. It's tuned to be very fast. At any time I can stop interactive rendering, and I can also save the image that is currently being displayed. If I switch to the Presto MC engine, you will notice that I also get a black image, and this is due to the fact that Presto MC is not using any ambient occlusion, and we don't have any lights. Now, interactive rendering can also happen inside Thea Darkroom. We can open Thea Darkroom by clicking on the fourth button, and this is how Thea Darkroom looks. We will be visiting Thea Darkroom again later on, but what we can see right now is that we can change to the interactive mode. We can select the Presto AO engine, and we will be using the Rhino's viewport resolution, and we can just press start, and you will see that we are in sync with the viewport. So any change to the viewport is being transferred to the Darkroom. Excuse me. This is very helpful in users where they have a multi-monitor setup. If you have a second monitor, you can move this. You can move Darkroom to the second monitor and have all the space working with Rhino. So we will be visiting Darkroom in a while, so we can close this for now. So what I would like to do now is to add some lights to the scene. And before doing this, I will start viewport rendering. And I will also turn off ambient occlusion, so we know the contribution of each light that we create here. I will be creating a studio setup with 3 lights, so I will use Rhino lights for this one. I will be creating rectangular lights. So let's create our first light. This will be on top of our scene. I will make it large enough because I want to have diffuse lighting and not having harsh shadows. So now you can see how that looks. So with a light selected, I can go to the Properties tab, and from here, by clicking the Thea Light Properties, I can change many things. One of them would be to make our light visible. So it's visible in rendering, as you can see right here. I would also be increasing the intensity of our light. I think it looks nice. So let's go on and create our 2 lights here. This would be our main light. This is also called in studio setups. This is also called keylight. I will turn up the intensity of this light to something like 300 or 350. Okay. And the next light I will be creating is the fill light. I will put it here. Oh, sorry, forgot to turn on copy. Okay, so since this will be our fill light, there's no point having it too bright. We can go with 200. And I will also be changing the color of the lights just to make them. I will make this one a little warmer. Maybe this one I will use a cooler tone. So now with our lights created, I will proceed with applying materials to our objects. So let's see how we create materials in Thea for Rhino. We just simply click on the plus icon and we select Thea Material. Now from here there are a few ways that we can create materials. The first one is by using the material browser. If I click on this button, I get the Thea content browser. From here on the left side, you can see that I have several categories. Most of them ship together with Thea Studio when you first install it. And you can also download new material libraries and collections that will always appear in here. So you can go to any of these categories, select a material. From here, let's go to the material flakes. Okay. I can select any of these materials and press OK, and it will be loaded in the material. Now, the second way is by using material presets. This is the drop-down. There are a couple, not a couple, there are lots of material presets here. You can create car paints, ceramics, color metals, plastics, and several other materials. This is a very nice way to create materials very quickly, and they can be a starting point. You can create the plastic materials, and then later on you can use the Material Lab to further edit it. So each material preset has a minimum set of parameters, so you can achieve your final look. So for the plastic material, we only have reflection, roughness, and way to include a bump texture. So the last way to create materials is by using the external Thea Material Lab, just by clicking on the Open button. This is the Material Lab. This is on the left. You see we have the same material library with categories that we saw in the Thea content browser. So I can either start creating my own material from here, or select a default material from here and edit it further. So by hitting accept, the material will be loaded in here. So let's start creating materials with the material presets. The first material that I would like to create is for the main body of our guitar amplifier. I will assign it to it. Okay. Now I will select the plastic preset, and I will select a dark gray color for this one. I will also increase reflection, and I would also like to increase roughness. I don't want to have sharp reflections in this one. Let me check. Okay, I will also enable, I forgot to enable the visibility for the lights. Okay. The next material is for the rest of the plastic objects in the scene. Let's create a second material. I will apply it to our objects. Now I will be using the plastic preset. I will give the same dark gray value and the same reflection and roughness for this material. Okay. Let's move on. The next material I will be creating is for the front face of our amplifier. It's a fabric, so let's create a new material, apply it to our object. So now I will be using the default material preset. It's the simplest material. It only has color or texture and the bump channel. So I will load the texture that I have for this material. Okay. Now the next material is for our cable. I would like to create a plastic material, but I would like it to be shiny. So again, I will be using the plastic preset. Let's use bright orange value for this one. Let's turn up the reflection up to 100 and slightly increase roughness. So it looks fine. Now let's create a metal for the metal parts of our amplifier. Again, I will be using material presets for this one. I will select the colored metal. This preset, the higher, the brighter the color, the more metal it will look. So let's apply this to our object. You can see the reflections. And I would also like to increase the roughness a bit. Okay. Now there's one more material I will be creating. It's for the battery, the main body of the battery. This is a simple material. I will be applying a texture that I have created for this one. Let's apply this to its body. Okay. Let's now increase roughness, not too much, and also introduce some roughness to our material. So I have finished adding materials with by using material presets, and what I would like to do now is to use material browser to import materials in our scene. So I can do this by creating a new material. This time I would like to apply a gold material to the logo of the amplifier. So let's select it. Okay, let's open Thea content browser. Now I will go to the metal category, and from all the materials we have a gold material here. By hitting OK, it's being loaded in the material that we created. So this is how it looks. There's one more material that I will be assigning with material browser. It's the one for the backdrop object. I will be selecting a wooden floor for this one. So let's apply this to our scene. Great. So now I would also like to create some more advanced materials, and this would be for the control panel that you see here. This is a metal surface having some text on it for the knobs. So we will be using 2 layers to create this one. Let's select it first. Okay. Let's create a new material. Apply material to our object. Now, let's go and open the Thea Material Lab. Now, I would like this material to look a bit like gold, like the rest of the gold material, like the previous material that we used, the gold one. So as a starting point, I will be using the gold material here. So how this works, I would like to create something like a sticker that sits on top of the material surface. To do that, I will be creating a new basic layer, and I will move it on top of the gold material. So now we see only the basic layer, and what we can do to control the opacity of this layer, or it can be done by using the layer weight. I will be using a texture map to control what can and what cannot be seen, and I will use this texture that I have created, their black and white values. In places where we have black, that means that we will be able to see the layer beneath it, while white means that the current layer will only be seen. So let's load this to our layer, and as you can see, we can only we're able only to see the letters. Let's also change the color of the text. Let's make it black, as you see. Now I would like to change the gold material and make it feel like it's being brushed. So I will use this texture, and I will be using it to the roughness channel. Let's also increase roughness. Now what the texture does in the roughness channel is that it uses all the grayscale values and starts applying it to our material from 0 to 30% based on the grayscale values. So now with the material ready, we can go and see how it looks. One thing I forgot to add for our first material is I would like to add a bump texture to it. I forgot to add it at first. This is a texture that I had. Okay, now you see the microsurface of our texture. But since the bump phase is too strong, I will lower it down to something like 10%. And this is how it looks. So now I have 2 materials that I would like to create. The first one is for the nose, and one for the LED light that we will make it look like it's operating. So at first, let's go and create the material for the nose. Sorry for that. Again, we will be creating the material with the Material Lab. As a starting point, again, I'm using the gold material. And what I would like to create now is to introduce some anisotropy to our material. And to do that, I can increase anisotropy. From here, I will use a value of 80%. And I will also be using a rotation texture that you will see it when we go back to Rhino. This is the gradient that we will be using, and this will control the rotation of the anisotropy. One thing I would also like to add is some texture to the bump channel. It's some concentric circles, the ones you see here. Let's also decrease the bump. Okay. Let's also apply it to the scene. And now you can see how the rotation map works, and this is how our material works. So now for the last material, for the lead, I will be creating an emitter material, and to do this I will create a new material, apply it to the lead, and for this one I am going to use the emitter preset. I will also use red color for this one. And what I would like to do, because I wouldn't like it to light the scene, in some cases it may increase render times, and because it's I wouldn't like it to light our scene, I will turn on passive mode, and that means that it will look like it's been lit, but it will not cast any light to the scene. Let's also decrease the power of the emitter. Okay, it has been applied. Let's start interactive rendering, and now you can see it being turned on. So, I think we are ready. All materials have been applied to our object. What I would like to do now is to go to the environment, and I would like to turn on the physical sun. We can do this by clicking on the sun icon that you see here, and what this does is that it opens Rhino's default tab for the sun. They are the same controls. We can turn on the sun by clicking on the on button, and we can also turn on the skylight. You can see it. We have Thea physical sky turned on to our scene, and of course by using the controls that you see here, we can control the sun's position. So basically this is how you use the physical sun with Thea. So I will now be turning this off, and I would like to show you how you can add image-based lighting to this scene. This can be done by going to the Environment tab from the Thea Render settings. In here we have this drawer that has the image-based lighting, and we will be using a high dynamic range image like HDR or EXR. I will be loading one. This is an HDR file, and let's also turn this on. So now with the image loaded in the background, it also lights up our scene, and we can control its rotation and the intensity of it. There are more ways to modify the look of the image-based lighting. You can have different images for the background image that you see. So you can use this image to light up a scene. You can select a JPEG, a high-quality JPEG image for the background. You can have a different image for the reflection or the refraction. So let's leave this like that. And I would now like to show you another feature, and this is the shadow catcher. Let me hide this one, the backdrop. Okay, there are some cases where you would like to embed this object, the rendering, and you want to embed this into an image, but you would need the shadows to appear. You would need contact shadows, and for this one we will be turning on the ground plane, and again we will be using the ground plane that Rhino has. And by turning this on, Thea creates an infinite plane, and right now you see that it has a default material. That's why it looks gray. And to make shadow capture, to turn this on, we need to create a new material. Let's also give this a meaningful name. And by going to the material presets, we can select shadow capture from the presets. Let's turn off strength. And what we will do now is to go to the drop-down menu and select shadow capture. What you're able to see now is that we have contact shadows, and this provides a way to integrate an image inside integrate the rendering inside an image. So let's turn off the ground plane, bring back our backdrop. Now let's move on to stage our scene. We will be messing with the camera parameters, and we can do this by going to the Thea Render Settings in the Camera tab. And from here you can see that we can sync the resolution to the one that the viewport has, or we can enter our own, and this will be the final resolution for the final rendering. So let's see how we can enable depth of field in this scene. The way to do this is by changing the pinhole value. This is the default value that leads to having no depth of field in the scene. So for that one I will be using a value to about 5.6, let's say. So you can now see that we have a depth of field. The reason that you see it being inside, being in focus, is due to the fact that it uses the autofocus function, and what this does is to trace the middle of the center of the image and see if and automatically grabs the distance value. So this is how autofocus works. In case you would like to make this more artistic and you would like to create a different effect, you can do this by picking your own focal point. This can be done by clicking on the pick button that you see here, or a more convenient way is by using the icon that you see at the bottom of the viewport rendering. This is the icon. When I click it, it turns to orange, so it's turned on right now. I can click anywhere in the viewport, and I can place the focal point anywhere I want. And so for this image I would focus around here, let's say. Now another feature of the on-screen buttons here, there is a way to use the eyedrop icon you see here, and by clicking anywhere inside the viewport rendering you can go straight to the material. So if you want to edit the cable, let's say, you just click on it and you see that the material tab gets updated with the material that you clicked here. So it's very easy. You do not have to go to any other settings or go through the materials. The last icon here, this one displays the NVIDIA GPU cards being used and the CPU. You can hide this at any time. There's one more thing that I would like to show you, and this has to do with post-processing. There is a tab here in the rendering tab. There is the display drawer. These are the display settings. With display settings, you can do post-processing. You can change the ISO. You can mess with the shutter speed, and all this leads to changing the overall brightness of the scene. So let's turn this back to 100. Yes. There are other settings for the brightness, the sharpness of the final image, the burn value. You can also introduce vignette to the final scene. And there is also white balance. And one feature that I like very much, this is the CRF option. This is also called camera response function, and by the drop down I can select files based on real cameras. For this example, I will select the first one. You can see that it gives a very nice color, a very nice contrast to our scene. I would leave this like that. So now, after adding lights, applying materials, doing some look development and some staging to the scene, introducing depth of field, this will be the final rendering of our product. So let's see how we can produce final renderings with Thea for Rhino. Let's stop this for now. Final renderings can happen by using the Thea Darkroom. Inside Thea Darkroom, we can change the mode to the production mode. We can select Presto AO engine as the engine that will be used, and we can also use the Rhino viewport resolution, or we can use the Thea resolution in case we have used a different value in here. I will leave this to the Rhino viewport resolution. So now I can hit the play button, but before I do this, excuse me, I would like to go to the rendering menu and give an overview of what we will be rendering. We have Presto AO selected. We'll turn the super sampling back to auto. We have ambient occlusion off. Let's turn this on for final rendering. And now what I would like to show you is the termination criteria. While the interactive mode can run forever in the viewport or inside Darkroom, the production mode can have termination criteria. And that means that you can set a samples limit, so when the engine reaches 512 samples, it will stop. You can also use a time limit, and you can say that I would like the engine to run for 5 minutes or 30 minutes. Now, if you have both of them enabled, whichever comes first, the engine will stop. Let's leave this back to 0, and that means that it's disabled, and leave the samples to 512. I would also like to turn on bucket rendering, so while rendering, I would like to see the final quality of the image. So we are now ready to start rendering. I would also like to tell you that you can see that we also have the display settings to the bottom of Darkroom. They are the same settings that we saw earlier in the rendering tab. They are both in sync, so anything I change here will also change to the display settings in the rendering tab. So I can do post-production in here. By changing the values, I can increase brightness before saving my image and all of the other settings. So with that, this concludes this presentation. I hope that you learned some stuff about Thea Render and Thea for Rhino. And if you have any questions, me and Patrick will be happy answering any of them.
Hi.
Thank you for watching.
Yes. Patrick, we
Hi,
have
Barbara.
one question. Yeah, great. First of all, thank you so much for a wonderful presentation. What a great tool. Rhino user will be very happy. I'm going to read you the question that we received just now. Do you plan on adding Lightmap HDRI Studio support to use in conjunction with the Rhino plugin?
HDR Light Studio?
Uh-huh.
HDR Light Studio is being supported. You can do this by going to the Environment tab, and you can add an HDR Light Studio environment and start working with HDR Light Studio. This is how it works.
Great. Yeah, we had a couple of questions about HDRI light, so I hope that answered. Great. And if you have other questions, please, we'll give you a few seconds to chip in. Yes. Yeah, we'll wait a couple of minutes to see if anybody else would like to. And also, next question. What about distribute rendering?
Distributed rendering is also possible with Thea Render. This happens with just clicking the network rendering. If Thea for Rhino comes with, if I remember correctly, with 3 licenses, so you can have 2 clients running in the same network. So if you hit network rendering, you will start seeing the local machine along with the other clients.
Okay. And what about GPU versus CPU rendering? What is the equivalent GPU of an i7 CPU for Thea?
These are maybe too technical for me, but I can tell you right now that you can see the difference in here. We already have 100 samples with Titan X, while the CPU, the i7, it has 70 with 260. You can see the performance here.
Okay, and do you support the new NVIDIA devices with their new architecture?
They are being supported. The latest versions need some more optimization, but they can, of course, they can be used, and I am right now using the 1080 GTX, and it works fine.
All right. Can you quickly demonstrate how T4R works with UV mapping in Rhino?
Can you please repeat the question?
Yes, of course. Can you quickly demonstrate how T4 Rhino works, Thea for Rhino works with UV mapping in Rhino?
I'm not sure if I correctly understand the question. You can change texture mapping from here, but I think this is not what the user wants to.
I don't know. Let's ask Joshua. Joshua, can you specify? In the meantime, I assigned you the question, George. Maybe if you read it, you can understand. Demonstrate how. Yes, that's what he meant. That's what Joshua meant. T4 Rhino works with UV mapping in Rhino.
Yes, of course it works. Of course it works. Any projection here, even unwrapped models, And in this model, I have also did some unwrapping to some parts of this. So anything is supported.
Okay, and there's a comment also for always from Joshua that says many times with Thea for Rhino, the texture will be broken amongst surfaces. Is it something that you can talk about?
The texture seems broken.
Yes.
I'm not sure I understood that very.
That's what he says. He says that sometimes the texture will be broken amongst surfaces. Can you be more specific, Joshua? Let's see if he can explain, can give us an example of what he means.
If it has to do with texture mapping, maybe at some points something was missed by me, and the unwrapping was not very very good from my side. But I don't think it has to do with Thea.
So he says, so you need to manually unwrap the surfaces for them to work the best, not the model, right?
Not really. Not really. It depends on the surface. In some cases, for example, for knobs, I used a simple plane, a box here. I used a box mapping. In this one, I used a planar UV mapping, and I am not sure. I think here I have, yes. This is unwrapped, so you do not have to unwrap everything. You can use anything. I mean, even in an unwrapped model, you will be seeing the UV seam at some point. So it's a matter if you are able to hide it somewhere that cannot be seen.
Okay, cool. Thank you so much, George. That was great. What a great tool, as I said. It looks really great.
Thank you
And
very
you
much.
made it look very easy, and thanks for going through all the details. I think this tutorial has been very helpful, and it will be very successful once we upload it on our YouTube video later today.
Great.
Okay, I'm going to take
Thank
the
you
screen
very
back.
much.
Yes?
And thank you everyone for attending.
Yes. I will take the screen back, and I would like to thank everybody for attending today's webinar. And here's where you can find Thea for Rhino on the Novedge page. Novedge is the best way to buy design software online. And for information on the latest specials and new releases, join the Novedge network on Facebook, Google+, and Twitter, and subscribe to the Novedge blog. To rewatch today's webinar or previous ones, come visit our Novedge YouTube page or Vimeo. And we have a lot of webinars on our playlist for every software taste. Thanks again, George and Patrick, for a great demo today. Looking forward to more Novedge webinars with Thea.
Of course.
Bye-bye, everybody. Happy holidays.
Bye, Barbara.
Bye-bye.
Thank you very much.